This example comes from section 5.2, transformations of sinusoidal functions. In this case, we don't have to go through all the steps of graphing, but we are asked to describe the transformations going from a regular y equals cos x function to y equals 2 cos 3x minus pi minus 1. We've been looking at this general format of y equals a cos of b x minus c plus d. You might even want to put some extra brackets here to emphasize what's being inside the cosine function. But we don't have usually a coefficient like this 3 there. This is parallel to some examples we saw earlier in the course where we had y equals f of x, and then they had y equals f of 3x minus 6. And a lot of people described the horizontal stretch correctly, but the translation was wrong because it needed to be factored out, and you'd have 3x minus 2. This example is very much the same. Really what needs to happen here is a factoring step to correctly describe these transformations. So if I take this down here and rewrite it as y equals 2 times cosine of 3 times x minus pi divided by 3, I'll be able to easily describe these transformations as a vertical stretch by a factor of 2 about the x-axis. That would be my first one. A horizontal stretch by a factor of 1/3 about the y-axis. You would have had those right, even if you didn't factor, but now it's a horizontal phase shift right pi over 3 units, and we have vertical displacement down 1 unit. Without factoring, you would have gotten this vertical stretch, the horizontal stretch, and the vertical displacement just fine, but the horizontal phase shift is the one place where this would have fallen apart if we wouldn't have factored that thing properly.